Hey everybody, it is time for Rockin' Monday. You know, this kind of got delayed a little bit. Now we finally get to do it.
And long time no see either. I know you just did the Facebook Live this morning. Lots to talk about.
Yeah, lots to talk about. You know, it's been a really active weather pattern. We were off this past week, so that's why you didn't see either of us. But there was a lot going on in the world, that's for sure. We had a crystal ball, which formed down in the Bay of Campeche and just west of the Yucatan Peninsula down in Mexico, and made its way off towards the north. And it actually caused a lot of damage along areas like the Mississippi Gulf Coast and down towards Louisiana, especially right there near Grand Isle, just east of Grand Isle, which is between the mouth of the Mississippi River and kind of, I guess, central south Louisiana, you could say. That'd be my best description there for people who may not know what I'm talking about, south of New Orleans.
And this storm is going to impact our weather here in Texas too. You know, we're on the west side of this system, so we're not only looking at triple-digit actual high air temperatures, but also triple-digit heat indices. So it's so important to be careful over the next couple of days. And I wouldn't be surprised if we actually have a heat advisory tomorrow. So I know that's something the National Weather Service was talking about. So it is possible if we reach, you know, a lot of us see triple digits today, we could have many counties under that heat advisory tomorrow.
Sorry about that.
So let's look at some of the comments.
Yeah, I was just bringing up Facebook, guys, on my phone so we can answer some of your questions. Matthew's on. Matthew, I hope you're doing well today, man. Marcus says hello. Lexi says hi. Vanessa says hi. Hello to all of you.
Hey, Lexi, and hey, Vanessa. We also have Emily from 2nd grade. Hey, Emily.
Yep. Matthew says he's upset because he's missed so many classes. Matthew, don't worry. Remember, you can watch them again on YouTube. These should all be on YouTube as well.
It's going to be a lot easier to find them that way, especially with the classroom playlist that we have on YouTube.
Yeah, it's a lot easier to find them on YouTube compared to Facebook. So, of course, we answer your questions live on Facebook, but if you wanted to go back and watch them, you can watch them either here on Facebook, kind of harder to find them though, or you can watch them on YouTube on our YouTube channel. And
we also have Ainsley joining us. Hey, Ainsley, you're also one of our loyal viewers. You know, today we'll be talking all about rocks, hence the Rockin' Monday. We'll probably toss in a lot of puns with this classroom. We've already thought of a ton this morning. So
yeah, Mondays rock.
Yeah.
Sometimes.
Yeah.
Sometimes they can be hard as a rock.
Yeah.
Difficult.
And sometimes the subject will be hard. So.
Yeah, you know, this is actually very different for us because in meteorology, you study the atmosphere. You study from the surface of the earth. Right above the surface, up. You study the atmosphere. So this actually required a lot of research for us too.
Yes, and not only that, but weather actually plays an important role along with chemistry, because you'll get a lot of chemical reactions that happen not only along the Earth's surface, but also below the Earth's surface. So within the crust, and also, you know, all sorts of different layers within the Earth itself. So we talked about the different layers. We're going to be talking about weathering and how weathering and erosion and uplift play a key role, especially in the rock cycle too.
Yeah, so a lot of weather stuff that we're talking about here, erosion and things that have to do with water, the water cycle itself impacting rocks. And you guys, we're actually going to bring this graphic up full because I think it'll be easier to see a lot of the stuff. So give us 1 second. Let's go ahead and bring this up full for y'all. 1 second, guys. We may cut out on audio real quick. All right, there we go. So we're back up on audio, and guys, again, a lot of different types of rocks out there. Rocks are, of course, composed of mineral material, things like sand and little other pieces of rock that can sometimes form into other rocks, and you know, they actually all kind of form in different ways, and that's what we're going to be getting into here.
And some of you may have talked about, you know, rocks in general in your science classes. So if you know the 3 different types of rocks, the main 3 types of rocks, go ahead and comment on this Facebook Live, and we'll do our best to answer and see if you get them right. But yes, there are going to be 3 main types of rocks. But of course, you have the simple definition there that you were talking about, how rocks are mainly just mineral material. So all sorts of stuff. And of course, weather and erosion, like we were talking about, play an important role when you go from one main rock type to another.
Yeah.
So that's going to be very interesting. Try to comment here.
I'm seeing Melinda says Sunday is almost over. Yeah, so Matthew says, where do rocks like to sleep? In bedrocks. Matthew, that is hilarious.
He's throwing in the jokes
yeah,
too.
I love it. I love it.
Okay, so we'll go ahead and forward this. So
Yeah.
if you don't know the three main types would be igneous rocks, sedimentary rocks, and metamorphic rocks. And we're actually going to start with igneous rocks in today's lesson.
Yeah, and igneous rocks, I guess that kind of takes us sometimes deep within the Earth's surface, sometimes.
So think of Hawaii. Hawaii is a place where you would definitely find more igneous rocks, especially with the U.S. So igneous rocks are formed by the cooling and solidification, that's a big word there, of molten rock. So basically you get this cooling and then these rocks begin to turn solid and then turn into molten rock. And so did you want to take it away with magma and lava?
Yeah, so magma is something that we find beneath the Earth's surface. That is pretty much the same thing as lava. It's just where it's found is what gives it a different name. So magma is beneath the Earth's surface. It's molten rock, and lava is molten rock that breaks through the Earth's surface and is up top. So if a volcano were to erupt, that magma would make it to the Earth's surface, some of it would at least, and become lava.
Right, and this is actually the first step when it comes to the rock cycle, or one of the steps to the rock cycle. So we'll definitely show you that. So the differences between magma and lava. Magma being under Earth's surface and lava being above Earth's surface.
Yeah, so in this picture that you see on the left side of the screen, you see the magma underground there. That's kind of a look at the Earth's surface from the side. You see that magma deep in the ground, and then you see the volcano going off. That would be the lava coming up to the top.
Right, so this is going to be miles below the Earth's surface.
Yeah, deep.
Right, so you'd mainly find igneous rocks in Hawaii, like I was saying.
So Matthew says, how fast does lava move and what can make it go faster? Well, Matthew, a few things would factor into that, including, is it going down a slope? How steep is that slope? Of course, gravity plays a big factor in pulling things to the surface. Just as a ball were to roll down a hill faster, that may not have as much of an incline. That may have more of an incline rather. Lava would roll downhill or flow downhill faster, much like water too. And I think that if lava were less dense, if it didn't have as much rocky material, and if it weren't as thick, if it was more liquidy, I guess is the best way to describe that, it would also flow a little bit faster due to less friction. And
also think of this big word, viscosity.
Ooh.
So how thick is the lava? How thin is the lava? And so the chemistry, the viscosity, like I was talking about, that's going to play an important role in, how fast that's going to move too.
Yeah. Nice. That's a big word. I haven't heard that word in a long time.
I know, right?
That was Meagan Massey, meteorologist Meagan Massey, bringing back. I haven't heard since college. I haven't heard that word since college.
Yes,
wow.
Viscosity. So of course there are two main categories. So now we're not only looking at the three main types of rocks, but now we're diving into the two main categories of igneous rocks, and this is going to be based on where they come from. So don't think too hard about these. Extrusive igneous rocks and intrusive igneous rocks. So extrusive, you're kind of thinking outside, right?
Right. I would say that's like on top of something that's easier to be seen.
Right.
I would say.
So think of like extrusive and exterior, and intrusive being interior. So inside with intrusive.
Okay.
So let's break down, the two main categories based on, where these igneous rocks come from. So we talked about the differences between lava and magma. We talked about lava being above Earth's surface. So again, exterior being extrusive. So that's cooling of lava on Earth's surface. And I'll, of course, show you a common igneous rock. In fact, this rock could be found in some of your kitchens.
Oh.
Yeah, so you could actually see this type of rock every day. So if you can guess that main one for extrusive and intrusive igneous rocks, or just an example of igneous rocks as a whole, it's something a lot of us see. So give us your best guess. So also intrusive, we're talking about, interior, inside, right?
Yeah.
So cooling of magma below Earth's surface.
And remember, magma is below the surface, lava is on top. So extrusive lava, we can see that. That would be where igneous rocks we can see are. And then intrusive igneous rocks below the Earth's surface, something that we typically can't see unless we were to break ground and go see it, would be magma below the surface.
Right. So they're actually there's a different name. So you may have heard this in your class too.
Roger got the answer,
granite. Yeah. So granite would actually be an intrusive, aka plutonic igneous rock. So intrusive and plutonic are the same things, but sometimes, people will go with intrusive or plutonic.
Yeah.
And then with extrusive, that being volcanic igneous rock. So again, lava, think of that. Common would be basalt, and that's kind of like a black or a dark gray, and it's a fine-grained rock.
Nice.
So remember that as being cooling of lava on the surface.
And Matthew has a question here, and this may take us off topic just a little bit, but I want to make sure I answer this for him. He said, if you saw some plants growing inside of rocks, how does that work? Sometimes plants can find little cracks to form inside of, not necessarily inside of rocks, but inside cracks. You can have a little bit of a plant form, and that crack could get wider and wider as the plant's roots grow. It can cause the crack to get wider. A good instance on how this may happen, and in an area here in South Texas, where, Enchanted Rock.
Yeah.
I drew a blank there. Enchanted Rock State Natural Area. So right now they don't allow dogs to go up on top of the dome. Now that's for multiple reasons. It gets really hot up there at the top of the dome, but also because the dogs may use the bathroom on the rocks. And if there's poop on the rock even, sometimes that could be enough of a softer material to where a seed, if there was a seed that could get there, a plant could grow. And that could cause the rock to crack even more, which would damage Enchanted Rock, which is this big dome. It's this big rock dome that's up in Gillespie County, north of Fredericksburg. We've been ourselves. We're big fans. But Matthew, kind of a long-winded answer there. But that kind of lets you know, yes, plants can grow, not necessarily inside of rocks, but in little cracks. And if that crack is even really small, if a plant can start growing, it can cause that crack to get larger and break apart the rock. So I hope that answered your question. We kind of took us off topic there a little bit. Sorry about that, Megan. But I wanted to make sure I answered your question.
No, it's actually on topic, and we'll be talking about plants further into this. But one thing we'll be talking about is sediments, and sometimes you can get plant matter in those sediments too. And so that's why sometimes when you have weathering and even erosion, like you were just saying about the cracks in the rocks, you can have plants grow in them sometimes. So no, we'll definitely, dive more into that topic. But I just think this is so interesting because we see igneous rocks, sometimes our countertops are made of this. And, plutonic being the granite that you see in there, that's a common igneous type rock that's genuinely, light colored and also coarse grained. And of course, that's going to be cooling of magma below the surface. So again, intrusive inside, extrusive outside.
Yeah. So very cool. Yeah, and that's a lot there about igneous rocks, kind of a cool rock type.
Yeah. And so basalts are actually mostly found in Hawaii themselves.
Oh,
so that's
cool.
A common, igneous rock that you will find in Hawaii. And another example of the volcanic igneous rock is obsidian. Have you heard of obsidian?
I have heard of obsidian, and we have some.
So it's a type of volcanic glass. So think of it that way. So you have, of course, a lot of chemistry, pressures playing a huge role in that. And of course, viscosity. That's a big thing too.
We have some obsidian somewhere in our apartment. I forget where it is though. We are rock people ourselves. But
I have a collection too, and I told Weather Chief Bill Taylor that I had a huge rock collection, but unfortunately I cannot find it right now. So hopefully I can find it soon. And I know, Matthew, you were talking about how much you love this rock stuff and how amazing it is. We'll have to see if we continue to do Rockin' Monday next week.
Yeah.
So we'll definitely have to see about that.
Yeah, and Matthew, you can keep typing. There's no problem.
Yeah, no problem whatsoever. Okay, so this is also important. The chemistry of magma, rate of cooling, actually determine the igneous rock formed.
Oh, wow.
Yeah, so that's kind of, you know, the cooling, the rate of cooling, and of course the chemistry with the magma. Yeah, that's going to be important to determine the two characteristics when it comes to igneous rocks. Very cool.
So we now have sedimentary rocks, and this is a type of rock formation that we see a lot in Texas. That image on the left, it looks sort of like Texas, but that may actually be closer on towards Utah. Taking a look at it, I'm not 100% sure where it is,
it's
but
Utah.
it looks very Utah-ish.
Yeah, I know there's a lot of canyons, so that's going to be important with sedimentary rocks. In fact, you and Matthew were talking about plants. So not only could, you know, sedimentary rocks are basically formed by pre-existing rocks or pieces of once living organisms, but also plant matter can be factored into that.
So sedimentary rocks form layers called strata. So just different layers of sediment, which is compressed over time before forming solid layers of rock. So these layers of sediment form together. And if you're driving down the highway, we actually see this when you're driving down the interstate on I-10. If you drive west, when you get closer on towards Comfort, Texas, this is on the way to Kerrville, you're going to see these rocky walls on the side of the interstate. That's sediment rock. You can see the layers.
And of course, you're talking about over time, right? So we're talking years.
Thousands to millions of years.
A long period of time. Let's just say that. So actually, sediment rocks cover a majority of Earth's rocky surface. And we have two different categories there too.
Clastic sedimentary rocks and chemical and organic sedimentary rocks. So clastic sedimentary rocks are kind of made of pre-existing rocks. Common form of this would be shale. We can see that type of rock here throughout Texas in many different areas. Chemical and organic sedimentary rocks are formed by the precipitation of soluble materials, so a little bit of chemistry here, or chemical reactions. So yeah, a lot of chemistry.
A lot of crazy chemical reactions too. So yeah, when we were talking about weather playing a huge role, chemistry with these different types of rocks, yeah, this is just showing you the evidence there.
Yeah. So rocks, one of the more common rocks that we see here around not just Texas, but the United States.
And also limestone is a sedimentary rock. One is also limestone.
Nice. Very cool. And that type of rock that we may have here in Texas, you see in people's homes. If you go into the cave, you'll find limestone. And stone is actually something that also helps to filter out water, and it can lead to very clear water. It's one of the reasons why there's so many clear rivers and streams in Florida and even here in Texas.
Yeah. So now we're going to the third main rock type. This is metamorphic rock.
Yeah, metamorphic rock really sedimentary or igneous, and then changes by heat and pressure. So it morphs. It was another rock type, and then it morphs into something else due to heat and pressure over time, extreme heat, magma, and by intercollisions and friction of tectonic plates. That's going to be the pressure side of things.
Right, the pressure side of things. Think of a state, United States of America, that has a lot of, let's say, earthquakes. And a lot of plates kind of shifting there. You know, where would you find most of the metamorphic rocks? Think about it for a little bit and let us know what your thoughts are in our Facebook comments. But I'll go ahead and say it, it's California. And you can actually see the metamorphic rocks based off the difference of color.
Wow.
So heat playing a huge role, the heat side of that's going to be the extreme heat from magma that we were talking about, and the pressure, and that's going to be caused by the friction of, you know, tectonic plates and their movements just a little bit there. It's just interesting, you know, different things to that. And this is going to be well below the Earth's surface once again.
Okay. So you know, it's cool to know that formed by other different kinds of rocks. And even though it's deep below the Earth's surface, sometimes we can still see it thanks to weather.
And Matthew, you wanted to know about marble earlier. Here's your answer. So an example, a common example would be marble. So erosion will help bring that metamorphic rock up to the surface. That's what I was talking about, how you can see the different metamorphic rock based on their color, the differences of color. Couldn't find a good picture to illustrate it, but think of, you know, rock layers, that top layer being more of a lighter gray. And then the bottom layer, you know, pink. So you have like different pinks and grays there. So that's going to show you the differences.
Very cool. And those examples, again, are just like what Matthew had mentioned earlier, slate and granulite. You can see metamorphosis by difference in color. Just a second, erosion. You know, that's a little bit of the water cycle. Remember, the water cycle is, you know, that water will evaporate, and then it will rain, and then erosion will occur. So that's a little bit there about metamorphic rock. And then we, of course, have the rock cycle itself.
So the rock cycle, let's begin with the rise of magma under Earth's surface. We were talking about that being intrusive, right? That's the intrusive igneous rocks. Then you have extrusive igneous rocks. And remember, extrusive being volcanic rocks. So that has to do with lava, right?
Yeah.
So then you have weathering, erosion, and deposition, and that will cause small rocks to become sediment. So more of like a grain of sand in a way. Think of that. So you have all sorts of sand and just different types of rocks to form and become the sediments. Well, compaction of sediments will then help form sedimentary rocks over time. So we were talking about that.
Yeah, so really cool stuff. You know, and sedimentary rocks, something that we see more of here in Texas. Metamorphism with heat and pressure then can possibly happen, and will make sedimentary rocks turn into metamorphic rocks after melting of metamorphic rocks. And the beginning of the rock cycle happens with the rise of the magma.
Right. So after the melting of metamorphic rocks, that third main rock cycle, you then have the beginning, and you start with the rise of magma. Yeah,
so it has a cycle just like what we talk about with the water cycle. Just, you know, a little bit of a different processes there, but the rocks can break apart because of that magma, because it's so hot. It can melt the rock, and then we start all over again in the process.
Right. So rock cycle, one planet, always changing, right?
Yeah, you know, and it may be always changing, but sometimes it's hard to notice just because it happens in a slow process. It's not as fast as the water cycle, where it's like, all right, it's raining. Oh, the water's going into the ocean. Up, it's evaporating again. It's happening all the time. It's just, it's hard for us to notice it.
We were talking about, you know, these rocks forming over a long period of time, and also the friction of tectonic plates too. So of course that's going to take a while, you know, to make these metamorphic rocks too.
Yeah, it will. So guys, really fascinating stuff here. You know, it's fun to always go off of the meteorology things every once in a while and talk about another, I guess, branch you could say of science, going into geology and talking more about cycles. So,
and I feel like it's all, you know, one puzzle piece to, and that makes sense. So you have weather that plays an important role with erosion, right? And you know, you have chemistry, and we just talked about chemical reaction these rocks, and also magma and lava and their viscosity and the consistency with that. So that's going to play an important role with, you know, how fast these rocks form and what they look like too.
Yeah, and guys, I hope you're paying attention to what's been happening over the last few weeks. You know, we've talked a little bit about different subjects other than just the weather. Science is all intertwined. You know, we all use the same kind of language. We all study different things. Like we talked about space for a while. We talked about now the Rockin Mondays.
Solar system, yeah.
The solar system. There's all sorts of different things, but it all hand in hand. And it's important to pick the topics in science class. I know some topics tend to be not as exciting as other topics, depending on who you are, of course. We're all different. We all have different interests, but it's always important to pay attention to those topics that you may have as much interest in, because it can go hand with what you learn in other areas.
Yeah, so we hope you enjoyed this Rockin Monday, talking about the different rocks. You know, study up on it, even draw out the rock cycle for us, and you can share that on Friday's Fun Time Friday too. Yeah,
and that's going to be, remember, send your stuff to us. We'd love to share it. Now I'm going to bring up something else too here. It's the schedule for this week. Tomorrow is Tropical Tuesday, so a little bit of a comeback. We took a break from Tropical Tuesday for about 2-3 weeks, maybe. It was 2 weeks.
Yeah, I think 2 weeks.
But because we had Tropical Storm Cristobal, I want to talk a little bit more about that. You know, where it formed, how it formed, where it impacted, why the impacts were so strong that it hit. Because there was a lot of damage down there in the Mississippi Gulf Coast. They had a lot of piers break apart. You had cars stalled out on the roadway. We had water over the roads. It was a lot of storm surge for just a tropical storm. And I say just a tropical storm, but we're going to talk about why you shouldn't take tropical storms lead, why you should still take them very serious, and why you should watch them very close.
And of course, it's going to be different heights as far as storm surge along the coast, because the storm movement, not only the shape of the coast, play an important role in that. So I'm sure we'll dive into it. Also, how it's impacting our weather here in Texas. You know, we're forecasting triple-digit high temperatures and heat indices. It'll feel like 107 degrees tomorrow. That's why I'm thinking I wouldn't be surprised if we see a heat advisory in place.
Yeah.
Today's going to be very hot. We have a heat index of 103 this afternoon. So yeah, just be careful if you're working outside. Take the frequent breaks. Stay hydrated. Keep the sunscreen handy. This heat is pretty early in the year for us. You know, typically we don't see this, kind of heat until, I would say, July, August. So we'll actually have near record high temperatures too.
Yeah. So kids, remember, drink plenty of water if you're going to be playing outside, because it is going to be so hot. You know, something that we did when I was growing up a lot is we would play in the sprinkler. I don't know if that's still a thing.
It's a thing.
Okay.
Yeah, it is.
Yeah, but that's a great day for it. Find a spot in the shade too. Try to stay cool. Wear plenty of sunscreen. Stay safe outside.
Yeah.
And we hope that you have a wonderful day outdoors. So, guys, again, this wraps up Cloudy with a Chance of Learning for today. Don't forget, we're going to be on tomorrow at 1 p.m. with Tropical Tuesday. Tropical Storm Cristobal. We're going to have a lot of fun talking about that, because we're going to be talking about not just where it causes impacts directly, but how the Gulf of Mexico is kind of like a giant bathtub. And even if something's happening far away from the Texas coast, how the Texas coast itself can have major impacts even from this tropical system, because we had some issues along the Texas coastline with high water. And we're also going to talk about how it still impacted us, as you mentioned a second ago, with how hot we are. So,
yeah, definitely.
A wonderful rest of your Monday, and we'll, of course, continue to keep you updated on everything right here at Ken's 5.
We'll see you later.